Hello everyone. In this video, we're going to be solving a very nice equation with the floor value. So we have the floor value of x plus 2 times the fractional part of x, which is something that I'm going to explain, is equal to 1.3. And we're going to be solving for x values. Now, this is an equation which is kind of like a number theory problem because we're dealing with integers here. Let's go ahead and take a look at some definitions. For example, what is the floor value? The floor value is basically you take an integer like 2.5 and you just trim the decimal part and you end up with 3, right? 3.5 becomes a 3. You trim the 0.5. So basically, you're looking at the greatest integer less than or equal to the number. In the case of negatives, the story is a little different. For example, if you have something like negative 2.4 and you're trying to find the floor value, you have to think of it this way. The number is the greatest integer that is less than or equal to. So you can't go to negative 2 because negative 2 is not less than negative 2.4. So this is going to be negative 3. In other words, you kind of round down to the nearest integer. And the fractional part is what's left over. So in the case of 3.5, you take the floor value, you end up with 3. 0.5 is the fractional part, okay? And when you add the floor value and the fractional part of a number, you get the number. And for negative numbers, think about what the fractional part is going to look like, particularly in the case of negative 2.4. Now, let's go ahead and take a look at this problem, but before that, I'm going to give you a couple more examples. For example, the fractional part of 4.78 is 0.78 because if you subtract the number x from the floor value of x from x, then you get the fractional part. The fractional part of pi, which you can write approximately as 3.14159, is going to be 0.14159 ... Of course, that goes on forever because if you subtract 3 from pi, 3 is the floor value of pi, you'll get that number approximately again, okay? So that's how we define the fractional part and the floor value of a number. And what about the floor value of an integer? It's the same number. The floor value of 5 is 5, and the fractional part is 0 because it's an integer. Great, so let's go ahead and take a look at our equation one more time. We have the floor value of x plus 2 times the fractional part of x, and that is equal to 1.3. Awesome. Now, one thing to keep in mind, the floor value of x is always an integer. So you're kind of looking at an integer plus 2 times a fractional part equals 1.3. So that might give you some clues on what x is going to look like. But let's go ahead and ignore all these things. You can definitely guess and check, but we need to make sure we find all the solutions. And guess what? To solve this problem, which I think is really, really cool, we're going to use, to solve this equation, we're going to use an inequality. How nice is that? Why? Because if the floor value of x is equal to n is an integer, then this implies that x is between n and n plus 1. Of course, this is kind of like a half-closed interval. X can equal n, but not equal n plus 1. Let me explain what this means with a numerical example. For example, if the floor value of x is 5, this just means that the number is between 5 and 6, which can equal 5 but not equal to 6. Why? Because if you have 5 or anything between 5 and 6, 5.1, 5.0009, 5.79, whatever, 5.99999, its floor value is always going to be 5 because you're going to be rounding down. Does that make sense? Okay, so this inequality, and this is, by the way, two-sided, but we're only going to need one side, is valid for floor value, which is a really cool way. Now, by the way, if you can solve this problem without using this method, please let us know because I'm only going to be presenting one method because that's the only method that I know of, okay? So we're going to start with that. We set floor value of x equal to n, which is an integer. N is an integer. And we're going to go from there. We have an inequality, but let's go back to the original problem. Now, one thing to keep in mind, what is the fractional value? How do you define it? Well, if you add the floor value and the fractional part of x, what do you get? You get x, right? Because x is made up of an integer plus the fractional part, right? So from here we can isolate the fractional part of x and write it as x minus floor value of x. And remember, we checked this with pi or 3.5. Like, for example, in the case of 3.5, this would look like 0.5. Make sense? So the fractional part of a number is always between 0 and 1. We can also say that, right? The fractional part is always between 0 and 1. It can equal 0, but not equal 1, because it's supposed to be less than 1. Okay? Great. So now let's go ahead and see how we can use this equation. But wait a minute. Didn't we set the floor value equal to n? So this can be written as x minus n. Beautiful. Now we're going to be able to replace the fractional part of x with x minus n in the original problem. Let's go back to the original equation. Floor value of x plus 2 times the fractional part of x equals 1.3. Now the floor value of x, we set it equal to n, and the fractional part just became x minus n from here, right? So we're going to replace it with x minus n. Wait a minute, didn't you say that you're going to use an inequality to solve this equation? Yes, but we're not there yet. First, we're going to deal with this equation, okay? Let's go ahead and distribute n plus 2x minus 2n is equal to 1.3. I know there are two unknowns, that's okay. From here, we're going to combine like terms. That's going to give us 2x minus n equals 1.3. Now, we're going to go ahead and isolate x from here. Why not n? You'll see in a little bit why I want to isolate x, okay? So let's go ahead and add n to both sides. So we're going to get that. And at this point, I could either stick to this or change it a little bit, like I want to write this as 13/10 so that I can kind of do the division easily. I mean, you don't have to do that, but I think it's going to make it a little easier for me. I don't know. X from here, if you divide both sides by 2, will become n over 2 plus 13 over 20. Kind of like the sum of two fractions. Do you need to make a common denominator? Probably not. You can if you want. So this is x in terms of n. And this is beautiful. You know why? Because by setting, now remember what we did, by setting the floor value of x equal to n, we got an inequality. Let's go ahead and rewrite that. By setting this equal to n, what did we get? We got x between n and n plus 1. Awesome. Now here's what we're going to do. We're going to replace the x in the middle with this. Beautiful. So that everything can be in terms of n. Isn't that amazing? I find it beautiful. So from here, n, and then replace x with n over 2 plus 13 over 20 less than n plus 1. Nice. Now, we can go ahead and do this. This is a compound inequality. So we kind of need to take 2 at a time. Let's go ahead and take a look at that. So we can, basically, we can break it down into this and this, okay? It's an and because something is between two things. Make sense? Okay. So now we can go ahead and solve each one separately and then use the and. Okay. Here, you can just subtract n over 2 from both sides. And that'll give you n over 2 is less than or equal to 13 over 20. Now go ahead and multiply both sides by 20. And then you will be able to, actually not really. Why would I multiply by 20? Sorry about that. I meant to multiply both sides by 2 because I think my goal is to isolate. Actually, you know what? My goal is to get n, so we might as well just multiply by 2. Exactly. That's what I'm trying to do. Okay. 2's cancel out. N is less than or equal to, and 2 goes into 20 10 times, 13 over 10. This is one of them. And this one, you can actually subtract n over 2 and subtract 1. So it looks like this. 13 over 20 minus 20 over 20, that's going to be negative 7 over 20, is less than n over 2. Or you can write it as n over 2 is greater than negative 7 over 20. Either way is fine, but I'm going to leave it like this. And now we're going to go ahead and multiply both sides by 2. Same idea. N is greater than negative 7 over 10. So we have this and this, okay? So how do you put it together? Easy. N needs to be greater than -7/10 and less than or equal to 13/10. In other words, it has to be between these two numbers. Make sense? Great. That's what's really cool about this method, because by solving this inequality, you're going to be able to solve the equation. But how? You might be asking, right? Here's how we can do it. We know that n is an integer, right? So there can only be so many integers between these two numbers. Now think about it. -7/10, and then the next one is going to be -10/10, which is -1, but -1 is less than -7/10. So between -7/10 and 13/10, you have the 0/10, which is 0, so n can be 0, or you have the 10/10, which is 1, and can be 1. So there are only two integer values between these two numbers. Make sense? And n equals 0 means what? So how do you find x if you know n? Okay, let's go back to our equation. What was that equation that gave us the relationship between these two things? Yes, 2x minus n is equal to 1.3, or 2x is equal to n plus 1.3. Since we're solving for x, you could go ahead and actually even use this one. I mean, it's totally up to you. Let's use that one. X equals n over 2 plus 13 over 20. Now, when n is 0, right, x is going to be 13 over 20, which is 0.65. When n is 1, it's going to be 1/2 plus 13 over 20, which is 10 plus 13 over 20. That's going to be 23 over 20, and that's going to be 1.15. So we have two solutions, 0.65 and 1.15 to this equation. The equation was the floor value of x plus 2 times the fractional part of x is equal to 1.3. Now let me tell you how you could have guessed this easily, right? Or sort of. Now, looking at this is an integer. So the fractional part, 0.3, comes from here. But it's 2 times the fractional part. So there are two possibilities. Either you're going to get like a 0.3 from here, and you're going to add it to x, or you're going to get 1.3. Can you get a 2.3? No. Why not? Because 2.3 equals 2 times the fractional part, means fractional part of x is going to be greater than 1, which is impossible. So there's only two possibilities, and these basically give you the value of x. How? That's for you to figure out. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out SyberMath and aplusbi, and bye-bye.